So I'm so excited that we have kicked off again. Our first Sundowner Rockstar for 2022 is Michelle Ash. Michelle is the CEO of Dassault Systems Geovia and has made significant contributions to the mining sector with a focus on innovation strategy, technology, and digital transformation. And I'm thrilled that she's joined us in the hot seat today to present on global ore body knowledge. So it's going to be an amazing session. Please use the chat. You'll have the chance to jump off mute and we'll open up the floor for some discussions at the end. And I hope you all enjoy it. So thank you so much, Michelle, for joining. It's wonderful having you.
Okay, well, a hard act to follow with all of those. Hopefully what I present is as interesting. So yes, what I wanted to talk about today is really around one of the 5 key problems that I think as an industry we really need to solve, called global ore body knowledge. So how do we understand and better understand our ore bodies? I'm just going to talk a little bit about some of the technologies that are helping, I guess, us solve those sorts of problems. And yeah, be very interested to hear the questions, the comments at the end, or during, if the mood takes you. Now, if I could just get my thing to go. Oh, there we go. So one of with, and actually I'm just going to do an apology. So I'm actually on the road at the moment. So that background noise is my car's air conditioner. So hopefully it's not too overwhelming for everybody, but it's 39 degrees out of the car. So I figured it's better to do this in the car. So yeah, what I like to start with all my presentations with is really just thinking about the environment that we're working in, and the fact that at the moment the world that we are living in is changing at an increasingly fast rate. And look, I know a lot of us know that or understand that intrinsically, because just even in our daily lives, the changes in the way we take on board information, we share information, just using our phones for everything from, reading the newspaper now, looking up things digitally and online, navigational tools, cameras, videos, it's sort of an all-in-one tool. But, I think the thing that's changing even more rapidly at the moment is the way we go. And in part, especially in mining, that's because we're still doing some catch up. There's been years in mining where I remember back when I first started in mining, I used to go to work to do a lot of my personal things on the weekends because, work had faster computers, better printers, better comms than we had at home. And then it shifted over time to actually be often in our personal lives, we had better equipment or faster equipment, to the point where I remember when I was running Barrick's innovation team, at one point I had IT as well, and I couldn't find my IT team half the time. And I'd give them a call and I say, guys, where are you? And they say, oh, we're down in Starbucks. And I'd sit there thinking, wow, you guys drink a lot of coffee. You're often in Starbucks. And eventually they had to cough up and say it was because the comms system was better in Starbucks than it was in our own buildings. But mining is catching up at an ever increasing rate, and we'll look at some of those technologies that they're starting to implement, because getting data, just like in our personal lives, getting data faster, being able to distribute it, being able to talk to people, our loved ones instantaneously, those same tools are the sorts of tools that are making our work environments, again, better, faster, able to get more information and more data. And I sort of liken this change that we're going through at the moment to being similar to a change that happened when I first started in mining. And I know I can see some of you, will remember this period when, as geologists, we moved from the big A0 sheets of paper and drawing geology and ore bodies on those A0 sheets with the crayons and the coloured pencils. The revolution that we're going through is similar to when we went from that to putting a lot of these things in CAD and using various different CAD systems. So whether it's Vulkan or Serpac or Minex or any of the sort of GEMS packages that we used to use, to the revolution that we're going through at the moment, which is not just to have that static CAD information, or using those sort of three-dimensional tools that we use, but how do we actually use new tools that are appearing, like parametric design, like some of the artificial intelligence, so whether that's computer vision, or whether that's looking at different spatial analytics, or some of the ones that are coming in terms of quantum computing and how that can help us even understand potentially the genesis of some of the ore bodies that we have. So there's quite a revolution going on at the moment, and that same level of discomfort that we had years ago when, we felt that we were going to lose tangibility, the feel, we were going to lose the sense of what it was to be a geologist, what it was to be a mining engineer or a mine geologist. Some of that is, similarly happening now. So how do we ensure that what we do and the expertise and our creativity that we bring as professionals is still incorporated into the work processes that we use as we go forward? And again, it's our role as leaders in the industry or leaders in our field, to prepare and our organisations for this change. So there are 5 system level innovations that I think as an industry we need to solve. And one of them squarely is in the realm of the geologist, which is around global ore body intelligence. And, there's a huge need for us to do that. If we look at a lot of the work by, whether it's Richard Shoddy or anybody else, that looks at the rate at which we mine ore bodies versus the rate at which we find ore bodies, or we find ounces, tons, etc. We're not finding ore bodies fast enough. And certainly when we do find them, we have limitations in terms of how much knowledge we have of those ore bodies. And so if we could change that, if we could use technology to find ore bodies 20 times as fast, to find them at half the cost, when we do understand our ore bodies, know them down to the last gram, to the last metre, so that we can avoid some of those costly mistakes that we often have, where we put shafts through the middle of the ore body, we put a processing plant on top of them. The ones that I've done personally, where we think the ore body's going left, and in fact it goes right, and so we've spent money putting in declines, etc., to get to what we thought was the ore body, but in fact it's not. And so that's what I incorporate in global ore body intelligence. And the nirvana, as I said, is to find things faster, cheaper, down to the last gram, to the last metre. The other 4 then flow from that, because if we can understand our ore bodies that well, not only will we find them faster, avoid those costly mistakes, but then, and as I say to a lot of people, it is geologists, it's the exploration geologists and the exploration teams that really create the value in our organisations, in our mining organisations. That's where we take dirt from worth nothing to worth billions of dollars. And the rest of us mining engineers, we just try to not destroy value as much as we can. We try to limit the value leakage, as we mine and as we process. And certainly if we knew our ore bodies better, it would also then allow for less of the disruption through that mining process and through the extraction process, because we could set up our mines better, we could set up our planning processes better, we could set up our metallurgical processes better, and hence have a much smoother ride all the way through. The other 4, just out of interest, autonomous and electric mining, so that again we can reduce the amount of waste that we move, because we can shrink things down, we can pull people out of the coalface, in some cases literally, put them into office environments which were much safer and healthier. We can run, as I said, electric operations, which certainly when you can connect to renewables and other technologies allow us to certainly have a much smaller footprint, much lower environmental impact. Precision extraction, in best case, removing just the metal, again, radically changing the waste, radically changing the tailings dams that we need, at best, understand the mineral that we're interested in and try to take the mineral out. Symbiotic development really is around rethinking the relationship between ourselves and our communities and our governments, and how we create wealth for those organisations or those stakeholders. And then the last one is rethinking some of the business models that we have, and in fact the entire mining business model, which starts changing and morphing as some of these other systems level problems are resolved. But I'm going to focus on the first one mainly. And look, one of the great things I think about the technologies that we have today is that technology is enabling us to rethink substantially our operations, not just certainly the 30 years that I've been involved in the industry, is we are fantastic at continuous improvement, about eking away that 1%, 2%, 5% improvements year on year, time over time. That said, some of our productivity statistics haven't been sort of fantastic over the last sort of few years, but that said, we have eked away improvements to the point where copper grades that we mine now wouldn't have been inconceivable 20 years ago, or gold grades that we mine now, again, inconceivable 20 years ago. But what technology is allowing us to do now, and it's because of the speed at which we can get information, we can integrate that information, we can understand how better to mine our operations, how better to drill, etc. We can radically change the way in which we work and the way in which we think about mining. And in that sense, we should be looking to disrupt ourselves, disrupt the way we do things with these new technologies. And that's, to some extent, again, the corollary, which is 20, 30 years ago when we moved from a purely paper-based geological processes, now looking to really virtualize some of our processes. And I'll talk a little bit more about how that or what that means. So lots of emerging technologies, and again, this can be quite confusing and confronting because there's lots of things out there. There's, drones and artificial intelligence and machine learning, which, actually are two pieces of the same coin. There's different things like augmentation, robotics, automation, etc. And it's hard to understand sometimes what all of these technologies can be used for. And so it's why I often talk about to people, focus on the problems that we're trying to solve and then think about which technologies are most appropriate for those problems. But, so what are these technologies enabling us to do, whatever their name happens to be? So there is a whole raft of them that are enabling us to get information faster and cheaper. And so, information, whether it be, grab samples using drones, getting, flyovers for different geophysical properties, etc. Again, you can use drones, you can use small aircraft, etc. Whether it's information actually on people, so about the temperatures that people are working in, their stress levels in terms of the work that we're asking them to do. Sometimes even we can use augmented reality to give them information, to get information from them, whether that be visuals, whether that be vibration information, etc. So there's a lot of information we can get from wearable technology. There's also a lot of information that we can get from sensors that we can mount to, whether it's drill rigs, whether it is into the bits themselves, whether it might be LiDAR or other information that we can take into the field. So all of these IoT devices prices are coming down radically in price. So if I take drones, for example, only about 5 years ago, drones would have set you back around about $200,000 to $150,000. Now you can get the same standard around about $15,000 to $20,000. Still expand comparison to the ones you can get for home use. But again, it depends on the sorts of conditions you want to fly them in, the weights, the payloads you want to use, the information that you want to get. Similarly with, with some of the machine learning and AI that we then apply to the data as we get it, there are now tools that allow that those information sets, those data sets to be put together pretty quickly and pretty easily. You don't have to necessarily, again, have armies of people extracting that information and doing the coding. The cheaper tools, significantly cheaper tools that we can use. So we can get a lot of information and we can get it rapidly because of using of comm systems. We can get it far more cheaply. And that's the sorts of business models, I guess, that organisations, whether it be Sensor, who's using a number of different data sources to then apply artificial intelligence and machine learning to really have a look at where there have been successful finds. What does the data look like where we've made successful finds in gold or copper? And then how can it use that information to predict where there might be successful finds into the future? Stratum AI, where they take production information, they apply that to mine geology and mine exploration, mine geology to improve the planning process, so it's a much faster cycle, so production data into mine geology, into your planning process, and optimising around that, and have got some increases in the ore extract up to sort of like 25%, or trying to take it back further into mine exploration. So what does that mean for where potentially more positive holes might be located? How do they reduce the mine exploration budget but still have the same success? And they could take it, potentially work at taking it back into further and further greenfields applications. And then Goldspot, who really look at using a lot of different data sets to predict who has the most likely exploration success. And certainly their business model was, whether it's still the business model that they're using, because I haven't spoken to them for a couple of years now, they used that to then lay bets on, in this case, Toronto Stock Exchange. Again, they may have broadened that in recent years as to which exploration companies might be more or less successful. So really guiding their thinking, guiding the geologist's thinking, rather than replacing it in all of these cases, augmenting the geologist. So one of the important technologies in making all of this happen, so especially the faster piece, is good comms systems. So, Wi-Fi 6 or 5G, a number of mine sites now starting to look at 5G, or it's satellite technology, which, again, a lot of exploration rigs, or more and more exploration rigs using satellite technology. Price is coming down, even for mere mortals like myself, who uses satellite technology when I'm in the middle of nowhere, like Roxby, north of Roxby Downs, to get information within a reasonable price range, but of course faster speeds available to commercially. And again, this allows us to get information. So what does speed mean? Again, I've spoken a lot about speed and how we speed things up. Can mean not putting in some of those dead holes. So you've got information before you have to drill additional holes. It might be to do with safety factors or safety information. You know that people, drillers, etc., are safe, that they're not stressed, heat stressed or other stressful situations. So again, it depends on the metric that you're looking for in terms of the success. But again, how do we get these finds faster, cheaper, is the name of the game. The way we think about energy is changing. So, again, used to be very carbon based, now a lot more renewable based. So, solar panels, etc. Wind farms more for mining companies. Small nuclear reactors, really interesting for both communities as well as mines, but again, still reasonable offtakes on some of those. But certainly solar, and we're starting to see a number of exploration facilities set out with solar. There's hydrogen and other things. I put that one in there mainly because one of the things that's changing radically is battery technology, which is one of the ways we then can use a lot of this renewable energy, store the solar energy, store some of the wind energy, but also it allows us to get further, more distance with some of the robotics. So some of the grab samples we might get with drones or robotic technology, and especially in environments where you don't want to put people or too far or too dangerous to put people. So, speeding up and reducing the cost of discovery. This particular example here is Bort Longyear's TrueScan technology. It's very similar to, or has some similarities to the lab at rig technology that IMDEX was developing, and certainly as Barrick a couple of years ago, we were working with them. But the idea in all of these cases is to bring the lab to the rig so that you can get information and data as fast as possible. So, whether that be XRF information, whether that be chemical information, do your scanning in real time, your core scanning, so that you can see in real time what the driller can see in terms of the core. You can then digit and integrating it into some of your models. The interesting thing with this sort of technology as well is, rather than some of the losses that we have with the grab sampling or the interim sampling, sending it to labs, potentially having chain of custody issues, having information lost, as well as just the time that it takes to do that. This technology, you can actually get much finer detail. You can take more samples. You can take them much closer together. Again, if this additional information is helpful to the work that you're doing, so you can get information maybe every 10 centimetres, 2 centimetres, rather than the typical sort of 2 metres, to try to create additional fidelity. And of course, once you have all of this information in digital form, you can then apply artificial intelligence techniques, so whether that's computer vision, which you would apply to pictorial information, whether that's other form of an analysis or analytics, or multiple factor analytics, which you might apply to some of the chemical data, some of the numerical data, to again better predict. So why are you doing all this? You're doing all this to help the geologist not only predict what's coming, predict what might be around some of these holes, but also some of the work that we've been doing recently is to use parametric design to actually try to think about how that geology links between the different holes, see if there's some way to garnish additional information, so more benefit from the data that you are collecting by drilling the holes, and or whether there's ways to think about the genesis of some of these formations slightly differently. And of course, what have all of this different data is to create different simulations. In this case, just a geological simulation where they're adding numbers of different pieces of information, bringing that in real time. Try to skip through some of this quickly. is to try to just integrate all of the data, do it in as close to real time as makes sense, so that we can try to speed up the process, reduce the cost. And again, you know, part of this is around trying to try innovations in a mining context before having to commit to these things in the real world. So, you know, again, integrating geology ultimately into the mining process. In this case, it's a caving process. Oops, it's decided not to play. Nope, it's decided not to play. So we'll skip on from the video that's decided not to play. So, you know, again, what I was trying to show with that one really was how, you know, understanding the geology, the geo aspects, integrating a number of different data sets along with the mine design and with the draw points. And you can run a number of simulations and interactions of the block cave, and seeing how it then breaks, how it runs, how it goes through the draw points, and really then creating an operational sphere. So we know all of the operational parameters under which that block cave will be successful. And so you can tell then whether the sphere is small or big. And the benefit of being able to run those simulations, not only it gives you confidence, or gives the operators confidence that they understand the geology, the geotechnical information, that the mine will operate successfully, and especially given that you're talking often about $4 or $5 billion worth of investment, but also that the short video can be shown to those people who are not so technically competent. You know, might be a general manager, might be board members, could be local community, and they can really get a feel for exactly how that operation is going to work. And again, these sorts of techniques and tools are able to more rapidly drive innovation, because one of the things often in our industry that stops innovation or stops us trying new or different things is the fear of not knowing whether it's going to work, and being comfortable with the way we do things, and seeing anything new as being risky. And so all of these, so those sort of simulation techniques, one of the big benefits of them is being able to reduce the extent to which people feel that issue of risk, and can lower the risk. So, you know, effectively, the more that we can model with the geology, model, design, simulate how that's going to work in practice, simulate the mine, do that in, or will enable people to achieve different outcomes faster, and the faster we'll innovate. And, you know, ultimately, the benefit is to link the simulations and the virtual world to the real world and back again. And you'll see here in this one, it's really taking some of the things we've designed and developed in the virtual world, taking then some of the actuals and integrating the two. So this is the simulation. The real world actuals as they're actually digging this or blasting it. So it's sort of the integration of the two. And the idea is then to optimize and feed information back into both the development, the virtual and the real. So the more that we use technology to solve these sorts of problems, the more that we're able to transform and rapidly transform our industry. But the interesting thing is, the more we use technology and we rely on technology, actually the more that people are important, because all of these technologies really are just there to help augment the creativity, the knowledge, the expertise of the geologist, of the mining engineer, of the drillers, of the people that are actually, doing some of the activities or making the decisions. But it's how do we augment that so that people can make faster, better decisions that reduce cost and ultimately lead to better outcomes. So speed matters, and in transforming our industry, it becomes quite fundamental. So thank you. That's everything that I had.
Thank you so much, Michelle. That was really interesting. There were a couple of good ones that came through the chat. There's lots of change and innovation available now. There are challenges of getting geologists to implement, use effectively, and get the perceived benefits of the new tech. What strategies do you think have worked and failed?
Yeah, so look, I think broadly, so there are a lot of strategies that have failed, trying to force people to make change. I always think that one of the things that makes us human is choice. The fundamental part of humanity is having some sort of choice. So, the more that we can work with people to make these technologies appealing, give people a sense of control still, because sometimes the resistance to change is, well, now I'm losing control, or I'm losing my expertise, or I'm losing, or the output will lose the benefit of that human insight, and really working with people to make the technologies work for them, make them easy to use, understandable. Again, I've seen a lot of some of these technologies resisted because people feel they're very black box-ish. So the more that our experts can get to understand these technologies, so especially AI, artificial intelligence and machine learning, and some of the outcomes that they have can be very confronting and very black box-ish. And one of the things that I found is the more we get, in this case, geologists, to also understand artificial intelligence, to understand machine learning, to understand exactly what's going on, and in some cases even be comfortable with programming, but we don't all have to go that far. But to at least understand how those processes are working, the more I find they're comfortable then with the outcome and the guidance that the outcome can give them. Similarly, some of the technologies around, some of the computer-aided technologies, the parametric design, etc., which just help us develop, whether it's a mine design or an ore body faster. Again, the more people understand it, the more they get to use it and to guide its development, the faster people will take on those different techniques and technologies.
Yeah. With all the mine information going onto a mine server, what happens to the server and its data at the end of mine life?
Yeah, that is actually a phenomenal question. And, one of the things I would love to be able to convince mining companies to do, because, one of the things we sort of know is that the more data we have, the better chance we have of spotting some of the patterns in the data, whether that's, a human spotting the data or, using these great tools that computers can help us with for a computer to spot the patterns, is having that data. And of course, at the end of the mine life there's a fantastic wealth of data, not only about the geology, but how it was mined, how it went in through the processing plant, etc. There is one problem, which is that data is still too siloed and not integrated enough. But if we could integrate it, and then if we convince mining companies to release that data into a more public pool, so that we could all, as an industry, get access to it and benefit from some of that data, and especially some of the data that's, and I think we get into this weird what's commercially sensitive and what's not commercially sensitive, but certainly information about the geology itself is, I would argue, not commercially sensitive. And in fact, I would argue that a lot of the production data is not commercially sensitive either, but others don't. Then, you know, the better we can use that information and make use of it. You know, and you know, I have been much more outspokenly, slightly radical about also, you know, even during the time that the mine is operating, you know, especially given that we have our mine lease, we have our exploration leases, providing information, more information about geology and successes, etc., that again would help benefit all of us by knowing, you know, what combination of information is successful and being successful. But yeah, at the moment, what is happening with that information is, I guess, slightly better than what's happening historically. So some of you are most probably old enough to remember, because I certainly do, all of those sea containers that used to be out the back of mines, with all of the paper in it and those archive boxes, etc., that was all of the operational data and the geological data and the blasting data and all that sort of stuff that used to hang out the back for 50 years or however long the mining company decided they needed to keep it. So one step up from that is now they're sitting on servers. And so those servers are sitting in the server rooms of these companies. When companies transact, one of the things that I do talk to some of the mining companies about is making sure that they get hold of that data and that information. So at least it keeps going with that operation. But one of the things I certainly think from a governmental perspective that they should be demanding as part of the handover process, you know, if we're now walking away from a mine and we're saying this mine is now closed and it's cleaned up, again, is that data so it can go into the public archives and be utilised. So yeah, data is super important, and I think it should be a lot more freely available.
Well, this has been wonderful. I'm so appreciative of you taking the time, literally on the road. It's awesome to have you come on and have a chat with us. So I'm really grateful for that. So thank you.
Thank you. Thank you all.